Hi guys, welcome to AA1-6 Parent Graph Transformations. For today, we are just doing part one, figuring out all the parent graphs, specific points, important points, so on and so forth. I am out today because it's my daughter's birthday and I just did not want to go to work. I wanted to stay home with her. So I'm leaving you in Dr. D's very capable hands. So as we move on, I you a couple of quick things when you are dealing with a graph or an equation. Should already have this written somewhere, but the domain is all the possible values of x, and the range is all the possible values for y. And some of those are easy to see in the graph, and some of those are easier to see when you're talking about the equation. Another piece of information I want to give you is the asymptote. So the asymptote is a line that continually approaches a given curve but does not meet it at any finite distance. So basically it's a line that your graph gets closer and closer and closer to, shrink you back down, but does not meet. So we note asymptotes with a dashed line every time. Vertical asymptote. We're not going to do oblique asymptote, so we won't worry about that. But in one of the graphs today, you have a horizontal and a vertical asymptote. Let's see if you can figure out which one it is. But this is the line approaching it, getting closer and closer and closer and closer. And mathematically speaking, it will never touch it. So that is what an asymptote is. So one of the parent graphs that I want to review is the linear, and I'm going to review the parabola as well. You probably don't need me to, but I also want to model what I expect you to put in your notebook. So you have a set of glue-ins, and each one has a graph and a table. So what I would want you to do, what I would think would be best for you to do, is to stray from the directions I gave you on that piece of paper, because I'd forgotten some stuff. Here are the things that I want to see in your notebook. One is the original equation. So right here, the linear is just y equals x. That's the parent graph equation. Then I want to see the general equation. And what I mean by general equation is the HK form. So a times x minus h plus k. And every single parent graph that you work with today is going to have some form of that. A is going to be out front, h is going to be bundled in somehow with h, k is going to be hanging out by itself at the end. And you're going to have a table. You have that table on your thing. It has 5 values. In some cases you may have to go beyond those 5 values, but not all of them. The general ones I suggest, -2, -1, 0, 1, and 2 for your x values. Then you get your y values out of that by putting them into the parent graph equation up here. So linear is obviously pretty basic. If x is -2, so is y, -1, 0, 1, and 2. So as I graph those points, 0, 0, 1, 1, 2, 2, -1, -1, -2, -2, and I create my line. That is definitely enough for me to know, for me to know what my graph looks like. So the other parts I want you to list on here are the domain with the linear. This is all real numbers. Whoops, that's an apostrophe S if you can't tell. And then the range, no restriction on y either, so that is also all real numbers. Just an FYI, that can be noted by that little symbol right there. It's like an R with an extra line on it, in case you haven't seen that before. And then, is there anything else I want you to know? General equation, domain, range, table, graph. Oh, then list if there are any asymptotes. This one has no asymptotes. And those are the things I want you to write on all of those graphs. In some cases, your graph of -2, -1, 0, 1, and 2 will not be enough for you to figure out what's going on with the graph, particularly when you get to the rational. So that is what I expect you to do with all of the following. Let's see, we got the parabola, which you should already have that information, x to the third, square root, cube root, cube root. I'm going to jump to that really quick. Cube root is what times itself 3 times, gives you that x. So for example, to give you a heads up on that, if I have, for example, 3 to the third power, that's 3 times 3 times 3, so that's 27. So what that means is the cube root, or the third root of 27, equals 3. So in case you hadn't seen that before. And then if you want to try to put that in the calculator to get the, goodness gracious, to just do the table, if you put 3 and then the little caret sign to the power of 1 divided by 3, that's one way to do it. That'll work on Desmos. You can also find the cube root button under the math menu on the calculator. So that is that. I'm going to let Dr. D help you out with any other ones that you're not sure what they are or what they mean. And there's also a key left behind for you. It doesn't have linear or parabola on there because you guys already have that. So I'm going to pause for a moment and let Dr. D turn this off and get you guys started on that. And then when we come back, I'll go over the rest of them. But until the end of class, good luck.